Hi, everyone. First of all, thank you to Beyond Blocks for organizing this amazing conference and for inviting me. Oops, let's go one back. I'm here to introduce the Definity project. The Definity project has actually been cooking since early 2015. We are very science, engineering, and product market fit focused. But interest in the project has been growing as people find out more about us. So what exactly is the internet computer, and why should you be interested in it too? The purpose of the internet computer is to host the next generation of the world's software and data. So it's pretty ambitious. Everything runs on software. And we're aiming at both private software systems through to mass market internet services. So to understand the Internet Computer Project, you have to remind yourself about what a computer is. Pioneers like Alan Turing and von Neumann described computers mathematically. And they described computers in terms of processing instructions and data. And it wasn't long, of course, before people created computers from physical machines. Now, this is a picture of a server machine, and the kind of machine that will make up the Definity network or back the Definity network. But a laptop's a computer, a smartphone's a computer. The interesting thing is a computer is defined really by those original mathematical definitions about processing instructions and data. And you can also create a computer from a network of computers. And that, of course, is the internet computer. So the idea here is that we connect computers together to make a kind of public supercomputer that the whole world shares, and for which we can extend its capacity by connecting new computers as the world needs, right? So, we can install more software, run more computations, store more data. So this internet computer will, of course, be backed by large-scale mining across thousands of hosting locations around the world. And the internet computer mining is very different to something like Bitcoin mining, right? There's no proof of work. These computers are held to their tasks by the protocol cryptographically, but essentially they're processing data and storing data. That's their work, right? There's no kind of wasteful competition to find the next hash beneath some target. But the people running these nodes that connect together to make the internet computer, of course, are doing it to earn tokens. So, like all decentralized networks based on blockchain, it's a token-operated network. And that means that you need these Definity tokens for installing software, for running software, for storing data, for governance, and indeed for mining. So I think this is especially important today. Definity is a true decentralized network. And that means that the Definity Internet Computer Network can be composed of millions of mining nodes, and they all have an equal role. There aren't any special block producers, validators, coordinators, or anything like that. you could have a network of 100 million mining nodes, and the cryptography and the distributed computing used within the system enables them to act equally, which of course makes the network far less vulnerable to attack. And I think this is important today because I think some people are losing sight of what a true decentralized network is. True decentralized network involves potentially millions of computers that all play an equal role. There aren't any consortiums of special computers or anything like that. And that's what gives you the kind of robustness you need to support software and services at scale. So what does the internet computer run? Well, there's a new standard for universal software called WebAssembly. I'm sure you've heard about it already. It was actually co-created by a Dfinity staff engineer who continues to lead the standards process. And WebAssembly is already, it's a fast developing standard, it's still evolving, but all of the main web browsers already contain support for the current version of the standard. And we see the next generation of systems having user experiences, UIs, that are hosted by web browsers and run on WebAssembly. So we see the next generation of software and services having WebAssembly, HTML-based front ends running inside the browsers. And we see the back-end support for these systems and services running on Definity. So it's an end-to-end WebAssembly system. I won't go too much into the technical details of the framework that we're producing for this. It's called WebCanisters. And the purpose of WebCanisters is to increase the portability and flexibility of software, but also to make software development much simpler. One of our objectives is to reduce the cost of developing, maintaining, and administering software. So we are producing this framework called WebCanisters that will provide WebAssembly developers with a framework they can use to create the next generation of software systems and services with enormous productivity. And these systems that are built on the internet computer using WebAssembly will have some very special properties. Okay? The internet computer supports autonomous software. This is software that can exist independently of an organization or person, with the purpose that you can create an open source business. So we think a lot of internet services in the future will actually be open source businesses, i.e. they'll be run using autonomous software systems with inbuilt governance mechanisms that allow them to update themselves. We support a super low-cost R&D model. We actually think we can dramatically reduce the cost of developing new software systems and hosting them. It'll be very easy for software systems hosted on the internet computer to interoperate. The platform, of course, is a blockchain, right? It's just a super fast, super scalable blockchain, super advanced blockchain. So it's a hack-proof platform, so systems will automatically be more secure. We provide performance and scale, privacy technologies, means for people to create, for example, internet services or private software systems that maintain the privacy of data, of user data. We believe we're producing a future-proof platform by defining tomorrow's standards that people can build on, right? Because companies don't want to be constantly migrating from one platform to another. They want to be able to build systems that have a long life. And there's some other kind of cool things. There's something called eternal execution, which I won't explain now, but it essentially means we have a different vision for how software should be written and hosted, and how data should be preserved. So what are the applications for the internet computer? And not surprisingly, they're pretty broad-reaching. You start on the left with just IT systems. There's private software systems run by companies. Things like, e-commerce systems, product and inventory systems, human resources systems. Pretty much any system that a company or organization might want to build today, or a government department might want to build a system that enables you to pay your parking ticket. Anything like that. Private systems. Industry platforms that are shared. So, a huge opportunity that a lot of people are looking at is the creation of sort of semi-open, permissioned systems that are shared by participants in an industry that, release some kind of efficiency or liquidity. So a lot of people are talking about shared supply chain systems, things like digital rights, medical records, ticket exchanges, anything, right? And you go through to internet services. So we believe that the internet needs to be re-engineered in a completely different way. Today, the internet is dominated by huge monopolistic companies who control the data and the APIs. And in the future, we think, in the same way that the internet computer enables systems, the internet itself, right, to host systems and data, the properties it will bring will enable the reinvention of internet services in an open way, so that they'll become open source businesses, i.e., they'll be built with autonomous software, with governance mechanisms that allows it to update itself. And we think these will eventually outcompete their monopolistic equivalents, right? Because they'll be able to develop quicker, and they'll benefit from a kind of mutualized network effect, because they'll be able to provide better guarantees to innovators who are developing against their APIs. So, you could build an open source sales force, right? You could create social media systems. You could create like an open dating app, anything, right? And we kind of think that's the future. Finally, finance. We want to support very sophisticated future decentralized financial systems. There's a project called Phi, which is a decentralized commercial banking project. We'd like to see that run on Definity, and more projects in the same vein. Of course, there'll be ICOs and fundraising, charities, that kind of thing. So the next question is, how is the network governed? There's a lot of talk about governance at the moment. And some of the solutions we've seen introduced, in my view, don't fit very well with the decentralized model. You have kind of consortiums of people and voting for special positions, all that kind of stuff. But Definity cares very much about genuine decentralization. We would never introduce some kind of special role within the network. So we actually have an algorithmic governance system. It's called the blockchain nervous system. And this essentially is, something that processes proposals. Proposals come into the system, and proposals can be, upgrade the protocol, manage network structure, modify network economics, patch some broken user system, freeze a miscreant system if some terrible, ISIS slave market pops up or something like that, mitigate a hack. And the blockchain nervous system decides upon these proposals and executes the ones that it adopts using privileged software that runs on the computer itself. Without going into the gory details, essentially it's backed by neurons, which are created by staking Definities. And these neurons can earn rewards by voting. And once you've created a neuron, you can only get the Definities back by dissolving the neuron, which takes some time. but you get rewards for voting, and you can automate the voting by making your neuron respond to other neurons. So that's why it's an algorithmic governance system. The important point is that it's fully decentralized. There's no boardroom-style voting. Right? There's no committees or people in special positions of power. It's fully algorithmic and decentralized, just like the overall network itself. So who is pursuing Dfinity? Because it's a project that hasn't really been out in the open. Although, as it turns out, we employ a lot of the world's best talent in cryptography and distributed computing, and many of us have been working in crypto for years. So Definity isn't backed by a company. It's backed by a not-for-profit foundation based in Switzerland. And the foundation pursues scientific research, system implementation, and when the network's up and running, it'll help with threat mitigation and network support. We have operations all over the world. We have a research center in Palo Alto, Zurich, and we have people in Tokyo, Germany, UK. We also have 2 venture capital funds that will invest in, which are for-profit, which will invest in companies or startups building on top of Definity. So they're not huge. One, I think, is 40, the other one's 50. One's in San Francisco, one's in China. We've got a third one, which is much, much bigger, which I can't announce yet, but it's in the works. The project itself has raised, I don't know, something like 200 million or something like that by now. And we're building out what we call a NASA for decentralization. So I think a lot of people today forget that it's all very well creating a proof of concept blockchain. Anybody can do it. In fact, today, the Definity test network is orders of magnitude more sophisticated than any blockchain in production today. But we would never release it because it's not ready. It's coming, but it's not ready. And we think that the world needs systems you can actually build production systems on top of, right? Not just proofs of concept. And we also think it's not just about technology, although we have some very sophisticated technology. It's about what kind of organization or organizations will support that network. So, our solution is to build out a NASA for decentralization composed of the very best research scientists, engineers, and so on in the world. And if you're interested in working on the cutting edge of blockchain, please have a look at the definity.org jobs page. So anyway, that's me. This video up here was taken a few weeks back in the Palo Alto Research Center. That's one of the current Definity test networks, comprised of a few hundred computers distributed around the world. It reaches finality in around 2 seconds, right? So it's fast. So if you think about it, like Bitcoin in expectation takes an hour to reach finality. That's 3,600 seconds. 6 10-minute blocks. Ethereum needs about 37 15-minute blocks or something like that. It's about 10 minutes or 600 seconds. Definity reaches finality in about 2 seconds. And it doesn't depend on some unsuitable, Byzantine fault-tolerant algorithm designed for a different network. It's completely driven by novel science that is created specifically for the decentralized network setting. Anyway, that's Definity. It's not a myth. It's really there. There are Definity networks running right now, and the project is bit by bit getting near to the point where it'll launch the Definity network. I don't know how much time I've got, but I can do a quick Q&A.
Maybe you can take a couple of questions.
Sure.
Okay.